Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer. I'll now turn it over to our speaker for today. So thank you all for joining us and let's welcome here Jochen.
Hello, hello. Trust everyone can hear me
Yeah, we
and
can
also
hear
see me
you
at
and
least.
see you.
Perfect. Thank you. So welcome to session 11 of 11. We had to postpone this session because I had travel plans kick in. But welcome. This is the last session of our Azure Developer series. I hope you've got some value out of this series. We might end up scheduling some sort of an exam prep session at some point in time, but we will notify you on our on the Reactor website probably about that. So I've, as per usual, I've got the hands-on labs, which you will see towards the bottom here. akka.ms/az204 labs, but that generally works for most of our courses. So if you know, for example, our DevOps course is AZ400, you can also type AZ400 labs. It'll take you through to those labs. This PowerShell link is predominantly for some scripts that you might come across in the exam. I'll also see if I can show some of that towards the end. Of course, the messaging topic is an interesting one. It also makes out a very small part of the overall course curriculum. I think it's something like 25% or something that these integration services form part of. Either way, the agenda for today is comparing messaging and events. We will look at the differences between the messaging component we're talking about today and what we covered in one of the previous sessions regarding event management, event grid, those sort of things. We'll compare them and understand when to use what. This is a very big part of the exam as well. If they don't delve deeper into the SDK for these different services, they might end up asking questions. For example, when would you use this service? You're trying to achieve this. Which of these services are best suited? Which of these services can cater for these and these requirements, for example? So it's important to get some sort of a diagram, at least, that you know that you can talk to. And then we will focus on storage queues and service bus. We're not going to spend too much time around the storage queues. We've covered this at least at a decent level when we spoke about storage accounts. But I do have a slide coming up on storage queues, and then we'll focus the rest of the session around the service bus, and then have a little wrap up towards the end. All right. So first things first. If you look at event management and you look at, for example, our event hub service that we covered in some of our other sessions, you might ask, but Johan, what is the difference between an event where I've got maybe some event telemetry coming in from an IoT device into an event hub? What's the difference between that and messaging, as we are clearly talking about now? And the answer lies very much in the following. Messaging is more a message that contains the payload, right? When we're talking about an event hub, you can really just see that as intermittent metadata, right? Telemetry information, a temperature, something like that. If you think, for example, of our event grid, something happens and you want to respond to that, that event that's actually happened. If you think about the service bus and something like storage queues, these two options over here, it should be quite clear that the type of message that ends up on the service bus or on one of these storage queues might not just be metadata. It might be a fully functional data structure that contains something like sales order information. And I often like to use the scenario where, what we are saying, let me just wipe this out quickly. What we are saying is I might have a variety of different point of sale systems, right? And all of these point of sale systems are essentially sending sales order information to something like, let's say we've got some sort of an ERP system. We've got some sort of a large ERP system, and that ERP system, let me just find my cursor here, and that ERP system, we're going to be fronting with some sort of an application. And this application is then going to post those transactions into our ERP system. But if you can imagine thousands of point of sale devices essentially posting their transactions, if this was something like a synchronous operation, you're eventually going to need massive scale here, right? If I've got thousands of devices pointing thousands of messages, I'm eventually going to require some scale here, and that scale can actually be quite costly, right? So what we try to avoid here is we are trying to avoid the capability and the functionality whereby, or the scenario whereby these applications are posting their transactions and the application needs to format this information and prep the information and dump it into the ERP system. All of this could be quite easily solved by something like this, as opposed to posting the transactions to something like an application server. What we can do is we can post the transactions to a queue. And that means that all of these point of sale systems that we're referring to can asynchronously now post their messages into the queue, and these messages are effectively going to sit in the queue until they are consumed or read or extracted from this queue scenario. And that means that now my application server doesn't have to scale massively and can probably also run on a type of a timer service where we're running every 5 minutes. We're reading in batch format from this queue and posting batch transactions off to the ERP system. So the concept of queues essentially implies that this message we've got here is in fact the payload. Unlike with the event grid, for example, and maybe a little bit less so with the event hub, where the event grid is just going to notify you when something has happened. When a blob was added, for example, the event hub is going to notify you about that, but the notification is not going to contain the blob. It's only going to provide metadata and references back to that blob, right? So the concept of using queues is quite a common architectural pattern, and what's important for exam purposes is that you understand the different scenarios and different use cases for these. I'll briefly go through them with you. I just want to stay mindful of the time here. So you can see the event grid is essentially event routing. This is a push component, and also what I refer to as a fan out component. Message size limit, very small. It's really just metadata that we're talking about there. We've also got a variety of different protocol supports, HTTP and MQTT from a protocol perspective. And then you can also see from a retention period up to 24 hours. Right now, there's a concept of a dead letter event grid as well, but that's something that you have to configure in addition to the default deployment. You can also see from a scalability perspective, it's highly scalable. It's also seen as serverless, so there's no real infrastructure for you to see or manage. And then you can see the use case. Reactive programming, I think, is quite a well-known term out there. And then also it's event-driven. So something happens and I want to respond to that. The service bus, in fact, let's quickly talk about event hubs before we talk about the service bus. We spoke about event hubs in the previous one of the previous sessions. This is more an event streaming type scenario. And what I mean by that is the ability for example, an IoT device to connect and stay connected and stream telemetry data through to the event hub. Right. So we're talking about millions of messages coming from thousands of devices, and a lot of them maintaining an open connection with that event hub, as opposed to doing a handshake connecting, etc. Large event streams or kind of anything that fits into into those messages. And then you can also see that we support a variety of different protocols. AMQP, we support Kafka in this. So if you've got a Kafka based application, you can essentially point it to a event hub endpoint, and that allows you to consume to store that data in an event hub. We've got more or less compatibility with Kafka, and then obviously also HTTPS. Anything we have in Azure, most things rather, are available via REST as well. Right, you can see there that the retention period for this can be up to 90 days. It also depends quite largely on what type of SKU you are using, and then you can see scalability, massive. Millions of messages per second that we can ingest there. Use cases for the event hub, telemetry information, big data streams. I would also say something like IoT type devices. That doesn't mean you cannot use storage queues or service bus for IoT devices. It's just that these event hubs are a little bit more sort of catered, or a little bit better suited for those types of scenarios. And then lastly, we've also got storage queues, and you can see that with storage queues, we're really referring to a simple type of queue. A lot of the same types of semantics you will have with other queuing systems, like the ability to peek at the message, for example, but not all of the enterprise level features that you might be accustomed to if you were using something like RabbitMQ series or something like that. You'll also notice there that we've got from 64 to 256 kilobyte message size limits, and then also available via REST HTTPS, and then also, of course, via our standard SDKs. All of these, of course, have SDKs. Retention period for storage queues, you can see there the default is actually 7 days, but you can also flag it with a -1 value, and that means that it's it doesn't ever expire off the queue. From a scalability perspective, we'll give you some scalability with storage accounts, but remember, storage accounts are really just a store and retrieve type capability. So you can see that from a scalability perspective, we can possibly handle the load, but you're probably under massive loads and enterprise style applications. You'll probably need additional features to be able to scale better, right? Think of things like dead letter queues, that sort of thing. We don't have those types of capabilities with storage queues. And this is very, very often used for things like background tasks. I want to pop something onto a queue, and I want something else to respond to that. And then the last one here, and I'm very happy to be spending quite a bit of time around this diagram, because this is also something you might find. This information is basically scattered all throughout our courseware, so it's important that you understand the exam. I'll ask some questions around this. And then lastly, as I mentioned, the service bus. Now, our service bus is essentially enterprise messaging, and what we mean by enterprise messaging is messaging semantics that you might expect in an enterprise environment. The ability for me to configure, longer time to live scenarios. The ability for us to have larger message sizes. You can see the 100 megabytes under the premium tier. What we're talking about here with the service bus is essentially a brokered messaging system where we can configure either queues or topics. More on that on the next slide. And then you can see that we can, we can have various types of sizes. It's important when you prep for the exam that you understand that each of our SKUs have got different parameters and properties. It's probably not just relevant to the service bus, it also applies to some of our other services where there are some limits. In the exam, they might ask you some of those limits, right? Just to make sure you understand that this version of this service and that version of the service, or that tier of the service rather, has got different features and different capabilities than the other tiers. So try to also at least read once through the different capabilities of these different options. Protocol support on the service bus. You can also see there that we've got there we go. There's my mouse over there. That we've got, AIM QP as well as HTTP or REST options. And then you can see the retention period on this is by default up to 14 days, but you can also set this to be a lot longer than that. We're talking here about premium. The premium service gives you the most amount of scale. Obviously, it's also going to come with the highest cost involved, but we're talking here more about enterprise workflows, right? Enterprise level applications where maybe things like the order of the message is important. Maybe something like a transactional ID is important, right? Maybe something like deduplication, that sort of thing is important. You're not going to get those features dealing with the storage queues, at least not to that level. So first things first, important to understand when to use which service. You want to do some simple background tasks and disconnect applications. Storage queues might be a good scenario around that. You just want to react when a blob is added onto a storage account. The event grid is perfect for that, right? You've got some big data and streaming data, possibly from IoT devices. The event hub is going to be, catering a little bit better for that. You've got an enterprise messaging requirement where, first in, first out order of message is important, deduplication, those sort of features, dead lettering, responding to a message that was consumed, like a reply to option almost. The service bus is going to cater much better for those types of scenarios. So as I mentioned, we've already spoken about storage account queues, but I think it's worth us just touching on a couple of these options again. In the exam, at least when it comes to storage accounts, they will place a large emphasis on the URL, right? You've got a storage account called Johan Meiberg in one long word, right? What is going to be the queue URL? What is going to be the blob storage URL? So for exam purposes, it's important to understand that for whichever service you are using, it's always going to be your storage account name, right? And then either queue or file or blob or table.core.windows.net. And then towards the end here, the name of your queue, the name of your table, the name of your blob container, the name of your whatever service you are using. So there's the structure, account, queue, and then there's the message. And of course, we've got a message SDK that you're going to be using. This message SDK will allow you to post and read messages from this storage account queue service. And you can see there the messages must remain under 64 kilobyte in size. And the default expiration is 7 days. If you are using the older version of the API, you can see there, 2017-07-29, and prior to that, then the message expiration will be a maximum of 7 days. If you are using something after that date, then your time to live for the message just needs to be an integer, and on top of that, you can specify -1 so that the message never expires, right? And this is I actually got this from the course material. So this is the level of detail they're going to be expecting when you're going to the into the exam. What I thought of doing is possibly just heading to my Azure environment, and then I'm going to go with storage account here. I'll just touch on this quickly. There's some of my storage accounts, and if I head for the storage browser here, I'm quite happy if it just gives me the option to do this now, because we've got some. There's the queue. You can see there's a sales order option. Yeah, just like I expected, and this might also be disabled. There we go. Add a message, and you can see there the message expires in X amount of time. Message never expires, and you can see there I can also specify some encoding. There's the message now on the sales order queue, and you can see there that I can essentially there's the message ID, the message body, insertion time, and other metadata. And then you can see that I can essentially dequeue my storage account queue for that matter. Right. So I'm not going to show this to you in code, but it might be worth looking at what they've got in the exercises. In the exercise on the online course material, they might be asking you some questions about the SDK for the storage account queues as well. So just be mindful of that. I don't think we've got time to go into that into too much detail. Now, that is storage account queues. And now, if you don't feel familiar with this, I urge you to go and look at the session in the series for storage. In storage, we cover authenticating against queues, authenticating against the storage account, and all those sort of things. That's why we don't cover them in this session specifically. Now, for the most part, I want to focus on the Azure Service Bus. Now, the Azure Service Bus is enterprise messaging, right? It's got all and more semantics from storage accounts, but it's got a variety of additional features. The first thing to familiarize yourself with when you prep for the exam is to understand we've got different tiers for the service bus. Let me just quickly head in here. I'm going to go for service bus. So there you can see there's the service bus. I've got one already, but I'll create one just briefly so you can take a look at some of these options. Let me just bump the font. And you can see that I can actually go and select my subscription, my prod subscription. I'll create a new resource group there called 204. And I'll give it a name, Jazz 204 SB, just to be clear. And you'll see that we'll give you an endpoint of the name of your namespace .servicebus.windows.net. Right? I can choose the pricing tier, but what I do want to do is I actually want to show you some of the differences here. And if I click on browse, then you'll notice it gives me some other options. First things first here, you'll notice that if I look at the basic tier can only create queues. The standard tier and the premium tier can create both queues as well as topics. We'll talk about the differences in a few minutes. Then you'll also notice that the maximum message size for basic and standard is 256K. You'll notice that for the premium tier, we can ingest up to 100 megabyte messages. Right now, if that's not big enough for a message, then I don't know. However, that's not big enough, we've got a collation ID that allows you to collate together different messages, right? So we do have options like that allows you to group or segregate messages in that context. Now you'll notice that the premium tier can also have queues as well as topics. You can see that there's a fixed pricing mechanism for this, whereas the standard and the basic tiers basically got a number of messages that you pay, almost like a pay-as-you-go type scenario. So I can choose my pricing tier here. Let's say, for example, the standard tier. You will notice if I choose the premium tier that geo-replication becomes available, right? So once again, when you prep for exam purposes, you can do a lot worse than create a table for you that shows you, hey, what are some of these limitations? I would definitely recommend. That's one of the things I would add into my prep for the exam is I'll have a table on each service showing what the main features are between these, or at least in on Microsoft Learn, make sure you understand how to get to that content so you can go and dig out this content on Learn while you're busy writing the exam. So I'm going to choose the standard tier here, and I'll head for advanced, where I can basically specify my TLS version as well as whether local authentication must be enabled or not. If local authentication is disabled, what this means is I'm going to have to authenticate against this service bus namespace using intra ID credentials. In other words, an actual username, member of a group, right? Anything that falls under a user and gives access like that, or something like a managed identity service, right? So you might have a web application, and the web application has got its own identity and can authenticate against this service using Azure Managed Identity, authentication. So I will enable local authentication. Otherwise, even my app won't work later on. So let's keep that enabled. Networking, as per usual, this is one of the usual suspects I like to refer to them as. The networking component specifies whether this service bus is going to be accessible from a virtual network subnet or whether we want to be able to access it publicly. If I'm going to build an application here now that's going to interact with this service, then I need public access enabled. Otherwise, private access needs to be enabled. You'll also notice that it's disabled. It's disabled predominantly because I did not select the premium option. Here you can see it's available again. All right. So premium comes with network segregation. The standard tier does not come with network segregation, only accessible from the public. And then last but not least, some tags. I like to just add this security control, ignore. Otherwise, I have my hands full with some of these controls we've got in place to ensure our subscriptions are managed well. Of course, it's busy validating all of this now, and you'll notice the first thing in the hierarchy or structure when we're creating a service bus component is to create a namespace. So we create a namespace. That namespace is essentially going to give you a subdomain on that earlier domain I showed you. And then out of that namespace, we can either go and create a topic or we can go and create a queue. Talking about that, again, the structure is important. We've got the namespace and then the queue and then the topics. The reason why that's important is for exam purposes, they might actually give you a script and say to you which of these items need to execute in the right order. And if you execute the queue script before you execute the namespace script, you might run into some issues. So it's also an order that is actually important there. Now, two things that we can create. We can create a queue, we can create a topic and a subscription. As you can see in this in the queue scenario, we will use queues if we only have one entity that is going to respond to the message, right? I want to post a transaction. So this is more or less a fan in. Ooh, that should be round. This is more or less a fan-in type pattern or approach. I might have lots of devices that are sending messages into the queue, and I've got one service at the back here that's essentially reading these messages off the queue, right? Almost like a many-to-one or a fan in type scenario. That's an in. Right. The second option, topics, is almost the opposite of that in a way. So once again, I can have multiple devices or multiple services or applications or systems that are sending the messages in. But with topics, what we want is we want not just a pub sub type scenario. We want a little bit of pub sub, but we also want a fan out type approach. So with queues, we're going to have one consumer of the messages off the queues. With topics and subscriptions, we're basically saying, hey, I want multiple services to respond to this message. And each of those services will get their own copy of the message, right? So you can see that topics and subscriptions are basically a fan out type capability. Even though we might fan in and have loads of devices sending messages onto the topic, I can again choose that every one of my backend services are going to take a copy of that message and process that message for whatever reason. A really good scenario around that, and I will show this to you just briefly. Just stay mindful of the time here. So you can see that there's my service bus namespace. It was created JS204SB. You will notice that they've got local authentication here is enabled. I specified that. There's my pricing tier. And then towards the bottom here, you can see that there's some shared access policies, right? I can go and generate, a SaaS of sorts and say, hey, I want to be able to manage the entire service bus, or I just want to be able to read, and that means just the listen component, right? But we can also create these down at entity level. Now, and I want to just pivot back here to our slides. Remember, and as far as the structure and the hierarchy is concerned, we create a namespace. We've already created a namespace there now, so the namespace is created. Now we want to actually create these different entities, right? And the one entity is going to be a queue. I'll demonstrate that first, and then we look at topics and subscriptions directly after that. All right, so let's head over to queues. There's no queues currently. I'm not surprised about that, but there you can see there's, create a queue. I can call it sales orders. I always call it sales orders, funny enough. And then you'll see that there's a couple of options here. Some of these point to the types of features we've got in our service bus. Some of them are just limits and thresholds you can configure. Now, first of all, you can see there's a message queue size. I can specify a message queue size. Of course, our premium plan might have bigger sizes. You can also see a message delivery count. A message delivery count means that if a message has been placed on the queue and someone created a peak lock on that message and then drops the lock again, and then creates another peak lock and then drops it, what that usually implies is it doesn't know how to process the message. So we can go and specify a maximum delivery count, specifying that each message can have 10 peak locks. Maybe I've got there's something different in one of these options or whatever the case is. But if it's not delivered or consumed from the queue after this number, it'll essentially be placed on a dead letter queue if a dead letter queue has been enabled. You can also see a default time to live, 14 days, but you can see that we can specify a maximum of, what's that? Something like 10 million or something like that. X amount of days that we can actually specify. I'm going to just leave that. At something like this. Time to live, and essentially, then the message will be popped off the queue. We've also got a default lock duration where we can specify how long we want to lock the message for. And then towards the bottom here, you will see some of these additional features. I've got a slide talking through this. So if you'll allow me to just quickly. The couple of advanced features of the service bus. You can see we've got something called sessions, all right? And with sessions, we basically are specifying the order of messages, first in, first out, guaranteed ordering of messages. We can also auto forward. With auto forwarding, I've got one queue here, I've got another queue here, and both of these queues are going to forward to another queue in another location. Possibly we've got a geo-distributed organization, messages are coming into localized queues, and then we are forwarding those messages to a centralized queue where we might be doing something like our accounting or something like that. Dead letter queue, very, very straightforward. A message is not processed in time, and because it's not processed in time, that message is essentially going to get pulled from the from the queue onto the dead letter queue, and we might have an application that responds to that, fixes the issue on the message, allows the consultant to say, oh yeah, this stock code doesn't exist anymore, and then typically from there place the message back on the queue to continue processing or something like that, or eventually remove the message or let the message expire or something like this. Scheduled delivery is the ability for me to add a message onto the queue and specify when I want the message to be consumed. So this is a really, really good example of banking transactions, for example, where I want to send my transactions all today, and then tonight at 12 o'clock, I want those messages to be consumed and to be delivered. Right? The ability for me to control that when I send the message. Now, the other option here, you'll see message deferral. I think I messed up the typo. It might be a typo there. Message deferral is where the consuming client can specify, I've peaked at this message, but I'm going to consume this message later on, right? Almost the opposite of scheduled delivery. We've got the option of transactions as well, where we can use a collation ID, and the collation ID might allow me to specify something like a transaction number, and then the service bus understands that those items belong together, and I can also consume those items together. The SDK allows for you to filter some of the messages. You might filter a message based on specific types of metadata, etc. Like, for example, the collation ID. Bring back all the messages that's got collation ID number 5. I know these belong together because we grouped them together using a collation ID. Auto delete on idle capability is also a pretty well-known phenomenon, if you like, in messaging services and messaging applications. Basically, the ability for us to remove our services from the infrastructure when there's no message that's arrived, or needs to be processed. So under certain conditions, nothing is in the queue, nothing needs to be processed, nothing is enlisted for later delivery, nothing like that, and we will remove the essentially agent, and that means that when a new message arrives, we will provision the resource and services again, but it does allow you to essentially, to not have all the resources allocated all the time. Deduplication, we can also, as opposed to just using the collation ID, we can also use a message ID, and and we can, ensure that we understand this message has actually been processed already. Just deduplication of messages. Authentication, we can use either intra ID, we can use a SAS, right, that connection string I showed you earlier on, or we can also use something like managed identity, which essentially falls under intra ID, if you think about that as well. All right, so there's essentially most of these options. You can see there: enable auto delete, enable deduplication, enable dead lettering on message expiration. Partitioning is an interesting one, because with partitioning, we can specify the partition to write to. And all we are basically doing is we are saying that the broker that is processing this message. There's some compute, there's some storage capabilities there that that we want to segregate them. And when we are writing messages onto the queue, we can then essentially specify, we are writing this message onto partition number 1, for example, writing this message onto partition 2. However, when we consume these messages, the messages, we cannot consume the messages directly from one of these partitions. So you still consume the message from the queue, and that has some ordering implications as well. Sessions is essentially, you can see there, first in, first out delivery of messages, right? So that I was looking for FIFO, but they wrote out the whole word there. And then you can also see for us to forward messages to a specific, to a specific queue or a specific topic, right? So what I'm going to do is I'm going to hit the create button here. This is creating a sales order queue. And in sales orders, you'll notice, because this is a queue, I've just got my shared access policies here. And there you can see there's something called a Service Bus Explorer. Now, what I've got here, I'm going to go for shared access policies. I'm going to add a new policy. I'm going to just call this one all. Of course, you'll never do this. You will always stick to least privilege and specify that this policy can only read or can only listen, for example. I'm going to copy. Should give me a long connection string in a second. There we go. There's a connection string. And there you can see there's the writer. And I'm going to paste that connection string in there. Right. So you can see there a service bus client that takes a connection string and options object, right? You can see there's service bus client options, and you can see there's service bus transport type. We can specify some of these options. We can also specify things like the message ID, for example, collation ID, all of these things. So there we go. The sender is going to be to sales orders. And then you can see I'm just going to batch a couple of messages out. I'm going to go to a reader here, and I'm going to do the same sort of thing. Paste that in there, and let's see this in action now. Close that down, and I'm going to go for my terminal here.
Johan, we lost you. Don't know if you can hear me. Let's just wait a minute, guys. See if we get Johan back. Doesn't look like it, so let's just give it another minute to see if we get Johan back, guys. He's traveling, so he probably has some connection issues. Okay, we got you back.
Yeah. Sorry, I don't know what happened there.
Don't worry.
Everything just went off. I apologize, folks. At least I'm back
Don't
here.
worry.
All right. So there you can see I've got I've got my can you see my screen? I think that's so they can see there's my my different applications. There's my service bus folder, and I can go and check for the right application. And then I'm going to just add another one for the read application. Let's open this in the integrated terminal. Not sure what happened there. Apologies for that, folks. So there's the writer, and I'm just going to do a .NET run here. So what this is going to do is this is going to write some messages onto that queue. In the meantime, I'm going to do a .NET run here as well. You'll see within a few seconds, it's going to write a batch of messages. It's going to then, here we go. There you can see 100 messages have been written. And you can see now my my consumer application is consuming those messages, right? I'm going to publish another couple of messages. Just wait for this thing to complete. It's going to be cooking all the way to 100, I suspect. All right. So now I'm gonna close out this application, and I wanna show this to you. I'm gonna publish a bunch of messages onto the queue. Now take a look here. I'm gonna head into my queue. You can see there's my sales order queue, and there's going to be 100 messages. Right now, I didn't demonstrate this as part of the source code I showed you just now, but you can see there's the mode that I spoke about: peak mode, receive mode. This is something that is actually quite critical, and you can see that I've also added it to the slide here. This is something we need to discuss. So how this essentially works, and it's very consistent across messaging platforms, is we've got the ability to read the message in one of two ways. I want you to think about the following scenario. If I've got an application, right? There's my application, and let me rather use my finger here. There's my application, and it's going to be reading the messages from the queue. If I'm using the receive mode, what's going to happen is the application will receive the message, and once the message has been received, the application will start processing this message. If this application at this point in time fails, the message is already consumed off the queue, and we cannot get that message back, right? If this application does not cater for that in some sort of a fail-safe way, then that message is gone. On the other hand, if we are using, let me use green here, if we are using the peak mode, it's a little bit like someone that's playing the cards on the table. Have you seen when they play poker professionally? They just lift the card like this. They're peeking at the card, but they're not flipping the card over. Peek is exactly like that. So the application can peek at the message, look at the message contents, process the message, and if the message processing is complete and we are content, then we can flag the message as consumed, and that will remove the message off the queue, right? And that's the two scenarios here. So take a look here. I go for peak mode, right? And I'm going to say peak from start. Just peak all the messages. It's going to come up with there's 100 messages. Now you can see I can specify that I want to actually just okay, this is a peak mode, and you can see if I just hit the refresh here, thinking how I want to demonstrate this, you can see the messages are still there. Peak again from start, messages are all there. Hit the refresh button. It's not here, but you can see there's still 100 messages on the queue. So with peak mode, I can essentially peek at the message over and over and over without actually removing it from the queue. Now take a look at the differences. If I select the receive mode, it's going to give me an extra dialog here. But if I say receive messages, there you can see receive and delete as opposed to peek lock. I click on the receive button. I receive. Ooh, you can bring all of them. Really, you can. So you will see now I've I've received the messages and not just peeked at the messages. It will take a few seconds. There we go. There's my 100 messages now. And this time, if I hit the refresh button, then guess what? My queue is empty. And the queue is empty because I use the receive mode. I read the message, but then I read the message off the queue. Okay, so that's also quite important to understand. So just a quick, a point around, the queues and the topics. You will notice in this instance, I've created a queue. And remember what I said, with queues, I'm going to have one consumer that's going to be consuming the messages from that queue. Take a look at the other option. Take a look at topics. I'm going to create a new topic and I'm going to call this one web orders. Right? Again, some semantics around that. You will not see all the same capabilities around topics that you have for queues, but there's my topic, and immediately towards the bottom you will see that there's subscriptions. So we're talking here about a pub sub type model. In this instance, what I've got is I've got my web sales order that has come in here. And what we want is we now want our finance department and the application for finance to be notified about this transaction. We want to let our warehouse people know about this transaction. We want to let our shipping partner know about this new transaction. So what are we going to do? We're going to create a subscription. The first subscription will be for finance application, the finance app. The second application, or the second subscription rather, is going to be for our warehouse application. And then the third subscription here is going to be for our shipping partner. So each of these applications and services, these ones over here, are going to get a copy of the message when we are sending our orders to the web orders topic, right? And that's the main difference between topics and queues, right? And again, in the exam, they might ask you about this, and you can see here that there's my financial application. You will see the financial application. You can see there's my Service Bus Explorer. All those same semantics still apply here, but the financial application will have its own copy of the sales order. The warehouse application will have its own copy of the sales order, as well as the external application of party. I've spoken through these advanced features already. I apologize for my screen going off for a couple of seconds there. But in conclusion, our messaging topic, covers both Azure storage account queues and also covers the service bus. But a couple of the concepts that I would get my head around is, first of all, when to use which of these services. There's diagrams online and on our Learn material you can also get to for that. And also remember things like message size, message retention limits, right? They might ask you questions around that. And then be comfortable with the service bus features. And that's that from me, folks. Let's see if you have any questions.
Yes, we've got a few questions. First question from Dalton. Can I say that by using Azure Service Bus, the common concerns about having a messaging system architecture composes of different approaches, such as topics, queues, are abstracted from the developer. I took off your screen if you wanna look in the studio.
Yeah, so if you can still see my screen, it's they refer to them as entities. So what you will do is you will essentially create a namespace, and in that namespace you'll be able to create some queues and you'll be able to create some topics, right? More than one of these, one or more of these. For queues, you're just going to have one consumer. Oopsie. That was not planned. For topics, you're going to have multiple consumers, right? So the exam doesn't really go into a lot more detail around that. I am going to see though if I can read your question a little bit more clearly. Can I say that using Azure Service Bus, the common concerns about having a messaging system architecture composed of different approaches? Are abstracted from the developer. Well, at least the service, right? Because keep in mind what you might be doing is your developer might currently be running something like a RabbitMQ series on prem. And if they're running RabbitMQ series, they're responsible for the server, all of those things. What we've done is we've packed these capabilities into a PaaS component, which means as long as they use our SDKs and our REST endpoints and things like that, then they don't have to worry about the infrastructure. It's a serverless infrastructure. I hope that answers the question, at least to a certain degree there, Dalton. Any further questions for your use case from architecture design perspective? You still need to decide if you will be using topics or queues. Yeah, so that is the main thing, right? Do you want multiple services or applications to have a copy of the message, or just one? And that will drive you either towards queues or either towards topics. Pretty straightforward how to link either a queue endpoint to topic. Yeah, 100%. The SDK makes it very, very simple. My question was more related to having a messaging structure composed of queues. I don't understand what you mean by messaging structure, right? And having much effort required to migrate the structure to the service bus. Yeah, it depends. It depends what you mean by that, Dalton. I think if you've got some sort of existing service, like for example, I know that our service bus SDK and service overall is, for example, completely compatible with a Java 2 messaging service, right? So if you're using the Java messaging service, we can basically provide you with compatibility with that. So it just depends what you are using, right? And a migration from one platform might not be as simple as just moving the messages. If you're coming from the Java messaging platform, for example, you might not have a lot of disruptions and code that needs to get rewritten. But if you're coming from, say, RabbitMQ series or something like that, or something like BizTalk or IBM MQ series, like something like that, you might have to follow a more well-known, reliable migration path. It might not just be a question of pointing your applications to the service and off they go. So it really depends. I don't think the exam goes into that level of distinguishing, right? So I see John has got another question. As soon as the message is read, is it deleted? Not really, John. If you look at the previous slide, I think I mentioned this. We've got a peak mode, and then we've got a receive and delete mode. If you are using receive and delete, yes, the message will be deleted when you are reading the message. If you are using peak mode, you can go and specify when you want the message to be deleted. So I think that's a pretty straightforward question or answer there. And looks like that's all the questions. Dalton, if you want to reach out to me, you're always welcome to. I'll put this on the screen here, akka.ms/Johan. That's my LinkedIn profile. So you're always welcome to reach out to me and ask some additional questions if I didn't answer your question specifically. But other than that, folks, for those of you that have attended all of these sessions, I appreciate that you took the time for this. And I thank you for supporting our sessions, and I hope you learn as much as possible. Have a great day further, and we will chat hopefully very soon. Thank you. Ciao, ciao.
Thank you, Johan. We'll see you soon with more sessions. So stay tuned for news here at the Reactor. We have lots of interesting series coming now in October and November. And thank you all for joining our session today. Thank you, Johan, for this whole series with 11 episodes that you brought to us. If you are looking to watch the previous sessions, you can find it in our YouTube channel. And we are always looking to improve our sessions and our experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the link of our survey on the screen or in the chat. We'll see you in the next one.